Hello and welcome to Module 11, Lesson 1. We're actually going to split this video into two shorter lessons. If I went with one, it'd be much too long. So we're going to look at vertex and axis of symmetry with quadratics. So identifying quadratic functions, we should be able to do that based on lessons that we did back with polynomials, but let's just make sure we remember. Here's a polynomial. I highlight the n there to show you that that exponent on there is 1. That makes it linear. So this is not a quadratic. The exponent the variable has an exponent of 2 here. That makes it quadratic. So that's what I'm looking for. This one has an exponent of 2, but the biggest exponent is the 3, which makes this a cubic function. We are not dealing with that in this unit. And then the last one here, s squared, it's quadratic. So in this lesson, I want you to be able to identify the axis of symmetry and the vertex on a graph, calculate the axis of symmetry and vertex without a graph, and find a maximum or minimum value on a parabola. So the 5 key features of a quadratic. So we're going to start with the first one, standard form. So take a look at that. Standard form of a quadratic is y equals ax squared plus bx plus c. A is just a number. It's the coefficient, that's a fancy word for a number, of the quadratic term. It's the number in front of x squared. B is the coefficient of the linear term, so it's the number in front of the just x. And C is always the constant, or the number that has no variable attached. All right, so here's this quick example. What's A, B, and C in this problem? Well, it's those right there. So A is 25, it's positive. B is negative 17, you do have to include the sign. C is 12. Simple as that. That's standard form. That's just identifying what standard form looks like. Second thing, the shape of the graph is a parabola. You should know this. We've talked about this before. It's going to make a U shape. These show up in life all the time. If you are aware of what those are called, you'll see these as you go out in public, maybe even at your house. Okay. You can see here the ball. You can imagine the ball going up. Okay. That follows the shape of a parabola. This bridge, you see it right there. It's like an arc. This roller coaster. I'm showing you all these because I want you to see that what we're doing mathematically shows up in everyday life. All right, so how do we know if the parabola is going to open up or down without graphing it? We've talked about this one before, so this is a review. We look at the A term. If the A value is positive, that means the parabola opens up. This is what opening up looks like. It looks like a smiley face. Okay, that's when A is positive. Here's an example of that. Y equals 5x squared minus 15x minus 22. The 5 is all that matters when we determine whether it opens up or down. It's positive 5, so it opens up. The A value is negative. Parabola opens down. Looks like a frowny face. Okay, there's an example of that. Okay, so does this one open up or down? Real quick, you should look at this and see that the A value is 7, so it's going to open up. All right, so that's what a parabola looks like. The third thing is the axis of symmetry. This is new. This is a line that cuts something in half. So you can see this picture here. If I drew a line right down the middle there, it kind of cuts it in half. How about this butterfly? Got a line that cuts it in half. For a parabola, the axis of symmetry is a vertical line that divides the graph into two congruent halves, or two equal halves. So here's a parabola. The axis of symmetry is the vertical line that goes right down the middle. If I fold it over that line, it's going to land on the other half of the parabola. All right, so draw and label the axis of symmetry here. You could probably do that. Drawn right down the middle there. Now that red line has an equation. Everywhere on that red line, the x value is 2. So we call that x equals 2. That's the equation of the axis of symmetry. Now, we're going to tie that into calculating the axis of symmetry. So let's do that. There is a formula. You will need to know this one. Write this one down, circle it, star it, make it stand out. This is a very big formula. You will use it a lot. Okay. What are those B and A in there talking about? Well, we're talking about standard form. We're looking at A, B, and, well, C is not needed, but standard form. A is the coefficient of the quadratic term. Notice where it goes in the formula. It's on the denominator, and it's attached to 2. B is the coefficient of the linear term. So you see how it's B in standard form, but in the formula, it's negative B. So it's we sometimes say the opposite of B. Notice that C is not in the formula at all. All right, so we're going to calculate the axis of symmetry for the quadratic function. Okay, so we're going to do that after we look in C. Does the parabola open up or down, and why? Just to make sure you remember that. The A value here is 1. There's no number in front, so we assume it's 1. So if it's positive 1, which it is, it's going to open up. It's going to look like that. Now we're going to figure out where that middle is before we even graph it. So the graph's here right now, but in the future, the graph won't be there. You're going to have to find the middle before you even graph, and you'll see that later. So let's go ahead and find the axis of symmetry. We're going to use this formula. Okay. A, B, and C, we're going to identify those. A is 1, B is -6, C is 9. So let's plug those in to the right spots. So be very careful here. I got a negative. I keep that there. B is -6. So yes, it's -6. We're going to do something with that in a little bit. On the bottom, it's 2 times A, or 1. What is -6? Well, that's +6. You see that's the opposite sign of what B was? It's going to happen every time. 2 times 1 is 2. 6 divided by 2 is 3. So my axis of symmetry has the equation x equals 3. And you can see x equals 3 right down the middle of that parabola. Let's try this one. Does this one open up or down? And why? Hopefully you see that it opens down because the A value is negative. Right? So let's find the actual axis of symmetry. B value, where is it? There's no linear term here. There's no just x. There's an x squared, but there's no just x. That means B is 0. That actually makes life pretty easy because what's negative times 0? Just 0. And then 2 times -3 on the bottom. So it's 0 over -6, but 0 divided by anything is 0. So my axis of symmetry is x equals 0. So this actually lies right on the y-axis, or it goes right through the y-axis. The y-axis splits it in half. And that's that one. Okay, so that is the end of the first part of lesson 1. In the next part of lesson 1, we're going to take a look at the vertex. So we'll see you soon.